Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. I'm going to continue with the door for the mini mill. And today's component is going to be one of the sides of the hinges. Maybe both sides depending on how much time I have. And we're going to start with this component right here. There's one left and one right, and the only difference between the left and the right is where the upper projection is right here, this boss on the top. It just shifts over to the opposite side for the opposite hand. Now, because this is so small, this is about 3/4 of a millimeter thick here, maybe the same up here, a little bit more, maybe 0.85 millimeters. And this is about a 3 millimeter round on the end, 125 diameter. So you can tell how small this thing is. If I were to actually make it actual size, it'd be about that big. Not that big. So there is a considerable difference between the drawing and the actual part. Always got to look for that little note in the bottom corner of the drawing that says scale 99:1. So that's always important to look for. I'm going to make this, believe it or not, in a rotary indexer on the mill manually at a 1/2 inch diameter round stock. And I'm going to start with it in the material. Let's see if we can find it. It's right there. That's how it's going to work. It is just a little bit too big for 3/8 diameter, or I would have used that. And I'm not gonna compromise and have broken edges on some of these parts. And I want the thing to be centered within the material. So I'm going to side mill the perimeter, rotate it 90 degrees, and then side mill the opposite side. That'll give me the part right on location where I need it to be, and give me all the steps that should easily be accomplished with the digital readout all set to 0. I know how far to come up and over and down and in and out and all around, so that should not be an issue. I'm looking forward to doing this. There's going to be a lot of stop and measure and record. Hopefully the second one goes a whole lot faster than the first one, but you get the idea. When it comes out of the machine for the first stop, I will stand it up, mostly. And from this presentation here, I will be able to slot it and drill the hole down here for the screw. And at that point, it will go back in the lathe, and I will part it off, measuring the thickness of this little boss right here as I do. And you know, it sounds good on paper, right? Let's get over to the machine, throw a piece of brass in the indexer, write down some numbers, and see if we can come up with a part that looks just like that. Let's do it. First machining step is to sweep the material. I'm hand holding this, so I'm not going to do it completely. Let's sweep it to find the center. This is the Y0 location, and that is all you got to do. And if you don't do much spin indexer work, let me give you a really good piece of advice here. Always double check that you are starting where you want to start before you make your first cut. There is nothing worse than doing something like this and finding that your first cut and your numbers are all skewed now because you didn't start on 0. So make sure that you are rotated around to the 0 position before you start your machining. It's always a good thing to double check. Okay, once you have your 0 started, load your cutter, figure out what the diameter of your cutter is, and the radius of that cutter is going to be the offset for all the dimensions on the drawing. My x-axis is zeroed at this point, so whatever step or feature I want to create, knowing the size of that end mill, all I need to do is accommodate either the radius or the diameter, and off we go. I will black up the end of the part here. Boy, that is bright, huh? I will black up the end of the part so you can see exactly what's going on. And all cuts, I will try to do all cuts from one side. If you can't, well then know what the initial flat is to establish your part, and then move over to the other side and do it. And hopefully when I'm done, I'll have a nice rectangle on the end of this. I zeroed out my digital when I faced the part off, so now any steps along the x-axis are true digital readout readings. Thicknesses will be established with a micrometer. You need to go 130 in on the X and end up with a 130 lug down here, which will ultimately turn into a 125 round. Let's do it. Anytime I'm machining a step like this, I always stay away from the vertical face as I'm creeping up on the horizontal face. And when I'm coming up on the final dimension for the horizontal face, I'll make sure that I creep in the x-axis or the vertical face so everything cleans up in one continuous pass. That'll keep the step marks or the lines out of the vertical face. When you need to establish a cutter to an established face, black it up with a Sharpie marker and raise the table until the cutter leaves a track in the Sharpie marker, and then drop the table and make finer adjustments to establish the final starting position of that cutter. It's time to start with some rounds and some holes. Then we can come back and part this thing off, and you can see the hinge starting to take shape. So we're going to put the hinge hole in now. Well, that's a heck of a way to make a part, ain't it? Certainly is easy to hold it that way. In the absence of a corner rounding tool, I'm going to put a 45-degree chamfer on either side of this block, and I am going to hand file it. Now, it does look off-center, and that is intentionally off-center because of the way the hinge functions. Not a problem. The flat should be tangent to the round when the round comes around after I file it. And holy mackerel, as soon as I get my finger in there, you can really tell how big that is, or not. Now I get to relieve the back out, since the impact from that rank corner tool would have been too much. In this presentation right there, thin it out, part it off. Actually, thin it out, stand it up, split it, drill it, and part it off. Way too much work. Way too much work. Well, after a few more relief cuts and a recharged battery in the camera, the profile of the part is starting to fall out of the material. And I think that you can see at this point how important sequence of operations can be, with this back area right here getting extremely thin, and the amount of material that would have been in contact with a radius cutter or a chamfer tool up here being greater than the cross section, the chances of this thing bouncing around like a diving board are greatly increased. So it is a 50-50 roll of the dice whether or not you want to do this back cut last to establish this thin section, or do this front cut last in order to establish that thin section. But either way, that little thin section is going to have to be addressed. The front gets a slot for the receiving section of the hinge that mounts to the frame of the little machine. And you can do that one of two different ways. Actually, you could probably do it about 100 different ways. But the best way to maintain the relationship of features on a part is to leave the part in the fixture while you're doing it. I can pull this out and stand this up and do it with an end mill across this way. Sure, not a problem. But to guarantee that it's going to be true to the part, the best way to do it would be with a slitting saw. Now, that in mind, the amount of material that you are going to impact on the end here with the slitting saw, is it going to overcome the cross section of the thinnest feature on the part? You know, these are all things that you have to take into consideration. Also, the direction of the cut. Since this is small, I mean, you can see how small that is. The probability of this part flexing and pulling into a cutter is pretty good. So you want the cutter rotation to push away on this part. If you were to rotate this way as you were coming into the part, chances are this little cross section here would yield to the cutter forces and the part would bounce right directly into the cut and blow up. Also, the hole being in the part reduces the amount of material in contact with the cutter as the cut progresses and helps to reduce the load on the part and the cut and the operation as a total. All right. Now that you're a whole lot smarter, or not, let's just put this thing back in the 90-degree orientation, such as it is right there. Touch off on the front, move in a little bit, make a cut, make some measurements, make some adjustments, and then come up with the final part. Ultimately, this piece will need to come off of here right about there, so that tab is really thin, and then it will have to stand up and get drilled at the same time, but not in that order, guys. I'm going to put that hole in this tab first from the front, this being the front, which will ultimately be the top in a vertical setup. I'll put that hole in first, and I'll take it over to the lathe and I will part it off and probably rub it on some emery to make it cosmetically okay. I'm also going to take that little point off of there too. That's bugging me. I want it to be cosmetically, visually okay. Let's do it. Enough with the talk. Let's make some chips. Now, moving on to the slotting operation, I'm going to do this with a stationary blade to locate the cut, but naturally it's going to be spinning when it comes time to make the cut. I don't want to scuff up the edge of the part. The blade itself is 51 thick. Oh, 51. That's about 1.25 millimeters, right? I'm just going to take a piece of paper and I'm just going to worm it between the blade and the part until the paper traps, and I can start all my math from there. Because I have greater sensitivity raising the table, that's how this is going to go. I'm not going to come down with the quill. The quill is locked and up against the stop, so there's no mistakes. Let's raise the table until I trap the paper. Boy, how's that for a camera angle? That worked out pretty good. Now, this is not a net size blade right here. This is a lot smaller than the actual slot will be. So anybody that says, hey, any run out in that blade is going to be a problem, you know, you're probably right. And if that's the issue, then by all means check the location of the blade to the part with the blade running. There we go. We got some drag. And you can see the gap on the camera. Get the blade off the part before you move anything else. It won't end well, especially with a carbide saw. All right, that was a 4,000 shim, so I have to come up 2 before the blade is equal to the bottom of the blade is congruent with the plane of the top of the part. And then I have to come up 25.5 to put the center of the blade on the center of the part. So 27.5 puts the edge of that blade, the center of that blade, on the edge of the part. Let's do that. And just as a little trick, I am not setting my knead dial to 0. I am setting my knead dial to 27.5 before 0. Okay, so that the knead dial is set on 72.5 right now. When I bring the knead dial around to 0, the saw will be in position and so will the dial. It'll make all the follow-up cuts a lot easier. There we go, 27.5 coming up. Knead dial currently on 0. And you can see that the center of the saw is on the center of the part. Now, in order to find the center of the part, just come up half the thickness of the part, which is 110. It is. That saw is perfectly on location for what I need to do right now. I'm just going to move the x-axis table in until the part rings on the edge of the saw, and I will set my x-axis digital to 0 at that point, and then dialing in the depth and thickness is just a piece of cake. Let's change the camera angle a little bit. Actually, just leave it right there. Now, to do this, you really can't see it on the video. I will be moving the table, not the camera, moving the table in and out while I'm doing this to assure that the part is going to come in contact with the high spot of the saw diameter. When you are working in close proximity with a tool like this to a part that small, and you have rotary tables set up and you have spin indexers set up and arbors and things that you don't want to see go crash, do yourself a huge favor. If you have a power feed on your table, turn it off. The last thing you want to do is accidentally engage that power feed dial and see everything go boom. I've seen it happen. It doesn't end well. All right, let's make the cut. Enough talking. Now, at this point, you have two options. You can offset the blade partially and rotate the part 180 degrees, or you can just raise the table a little bit, lower the table a little bit. But either way, make sure the cut is done in rejection. And I'm going to change the camera angle here to illustrate that. That's really important for a delicate part. You can see the thin part of the component is right there. So this is going to have a tendency to flex that way, away. You do not, and I'm going to greatly exaggerate this, you do not want to make a cut like this, starting like this and feeding the part into the blade. The part is going to want to follow the radius of the cutter, and it's going to bend it and blow it right off. By rejection, I mean this way. As the pressure from the cut approaches and makes contact with that part, it's going to push it away, flexing this and not pulling it into the blade. It's going to reject it. It's going to push it away. And that is exactly what you want to see happen. You don't want to see it bend. That would be bad. All right. I'm just going to raise the table and lower the table a little bit to get my desired thickness. I'm also going to rotate it probably off camera and check the width of those journals to make sure that this cut truly is in the middle. Let's do it. Stop talking, get it done. Loving it. I'm going to spin this piece around. I'm going to put the opposite end sticking out, indicate it true to the world with a pin through the holes in this orientation, flip it 90, and repeat this process for the other end of this part. And this is where you start holding your breath. There's a lot of time invested in this little piece. Next step in the process, return the part to a V-block oriented so that it's true with one of the surfaces. Put it back in the machine and drill the hole. Now, since all the dimensions on my print were given from the center of the material, and that's the way the part was initially made, it should be a piece of cake to just offset and drill the required hole right in that tab. All right, pop it out, get it over to the lathe, part it off, and keep our fingers crossed that it fits. That's an awful lot of work for a small part, times 2. Here we go. With the part back in the lathe for the final operation, it is the thickness of this tab right here that needs to be established. I'm going to make a very superficial cut, measure it, make my adjustment, and part it off. I may have to break it off towards the end because of the geometry of the part. It's not exactly round. And I don't want the part sucking into the tool and blowing up just before it drops off. Now let's see what happens. I'm going to clean these guys up, try them on the door. Fingers crossed. Well, there you go, guys. The lug that will be mounted in the frame and the frame modification itself will be the next video. I think we're going to call this one a wrap. I cannot show you this on the frame right now because the frame does need to be cut out to accommodate for the bottom of these lugs. That is not a surprise. That's on the print. And if it's not on the print, I'll put it on the print after I do it. You know how that works. But there you go. Hinges. A whole lot more work than I thought it would be. And I think next time around I might just go for staked pins and make this a permanent installation. But I wanted them to look small and presentable. And let all the hardware and hard work show up in the back. I like being able to take things apart after I put them together, pressing them together, welding them together, staking, pinning them together. It's it's got its place. But as far as I'm concerned on a model, I like to be able to take it apart after I'm done. There you go. That's a wrap for now. Wherever you are in the world, I hope you're well and happy and safe. I'm Joe Pye, Advanced Innovations in Austin, Texas, saying thank you for spending some time with me today. I'm out. All right, I'm going to cheat. I'm going to show you anyway for everybody that hung in all the way past the credits. It's like waiting for the outtakes, right? There you go. You can see that the area right directly under the hinge does need to be taken down. The hinges are engineered such that they do not come in contact with the shelf on the inside. And I'm going to go with individual pins just because I think it's going to look better. There's the final placement. I like it so far. And yes, I will round the doors. I will round the outside corners, and I will round the entire outside edge by hand and very mildly, but we're going to get away from that sharp edge. Not going to blast it for now because it's a little harder to go back after you blast it than it is to just say, I don't want to blast it. So we're going to leave it shiny for now. I think that's a nice contrast. There you go. Boom, bonus material. Thanks for hanging in, guys. Take care. Stay well.